Imagine you're running a business and you want to predict how much a new hire should be paid based on their years of experience. Or maybe you're an analyst trying to forecast next quarter's sales. How do you turn all that data into a reliable prediction? That's where linear regression comes in. Welcome back to Knowledge Academy's YouTube channel. In this video of machine learning series, we're going to break down the basics of linear regression, a key tool that helps us make sense of numbers and trends. Whether you're new to data science or looking to brush up on the fundamentals, this series will equip you with everything you need to know. Ready to unlock the power of data? Let's get started. So, what exactly is linear regression? At its core, linear regression is a method for modeling the relationship between a dependent variable and one or more independent variables. It's all about finding the best fitting line that represents this relationship. For example, if you want to predict someone's salary based on their years of experience, linear regression helps us draw a line through data points that best predicts the salary based on years of experience. This line is what we call a linear model, and it can be used to make predictions. Now, let's break down the basic equation of linear regression, that is y equals to mx plus b. Here, y is the dependent variable we're trying to predict, like the salary. X is the independent variable, like the years of experience. M is the slope of the line, showing how much y changes for each unit change in x. And b is the intercept, the point where the line crosses the y-axis, representing the value of I when x is 0. This equation is a mathematical representation of a straight line, and in linear regression, we're trying to find the values of m and b that best fit our data. Now, linear regression comes in two main types: simple linear regression and multiple linear regression. Simple linear regression involves just one independent variable, for example, predicting house prices based only on square footage. Whereas multiple linear regression involves two or more independent variables, for instance, predicting house prices based on square footage, number of bedrooms. Both types are widely used, depending on the complexity of the problem you're trying to solve. Now, why do we use linear regression? Well, it's one of the simplest and most interpretable models in machine learning. It's easy to understand and implement, which makes it a great starting point to beginners. Linear regression is also very useful for understanding relationships between variables. It helps us quantify the strength of the relationship and make predictions based on the data we have. For example, businesses can use linear regression to forecast sales, predict stock prices, or estimate the impact of marketing efforts. One of the key concepts in linear regression is the line of best fit. This is the line that best represents the data points in your dataset. But what does a best mean in this context? The goal of linear regression is to minimize the differences between the actual data points and the values predicted by the line. This difference is often referred to as the error or residual. The line of best fit is the one that minimizes these errors, providing the most accurate predictions possible. We use a method called ordinary least squares, or OLS, to achieve this, which we'll explore in more detail in future. Linear regression is used in a variety of fields. Here are a few examples. First is finance. It helps in predicting stock prices or economic trends. Next is marketing. It is used for estimating the impact of advertising campaigns on sales. Next is real estate. Here, it helps in predicting property prices based on various features like size, location, and condition. Next is healthcare. Here it estimates disease progression or treatment outcomes based on patient data. Wherever you have a continuous variable that you want to predict based on other variables, linear regression is a powerful tool. Now that we've covered the basics, let's bring everything together with a practical example. We'll use a CSV file containing data on house prices, along with various features like square footage, number of bedrooms. A link to this dataset is given in the description below. We'll plot the data and then use multiple linear regression to predict house prices. First, we'll load the dataset into a pandas data frame. Pandas is a powerful library in Python that makes it easy to handle structured data. So first, we will import pandas and then read the CSV file, and then print the data to check if the data is loaded correctly or not. Now run it and you can see data present in your dataset. Next, we'll define our independent variables, also known as features, and the dependent variable, the target we're predicting. The independent variables in our case are square footage, number of bedrooms, and house age. The dependent variable is the house price. We will define it as x equal to data then, in square bracket the column which we are taking as independent variables. Then y equal to data again in square bracket, then the dependent variable. X stores the independent variables, that is features. Y stores the dependent variable, that is house price. With our data prepared, we can now create a multiple linear regression model using scikit-learn, a popular library for machine learning in Python. We'll fit the model to our data, allowing it to learn the relationship between the features and the target. So, we will first import linear regression from sklearn.linear model. Then we will create linear regression model as shown. Then we will fit the model to the data by writing model, fit in bracket xy. Once the model is trained, we can use it to make predictions. Let's predict the price of a house with 2,000 square feet, 4 bedrooms. Here, this creates a NumPy array with the specific values for square footage, number of bedrooms. This uses the trained model to predict the house price based on the input features. Then print statement is used to predict price, formatted to 2 decimal places. To better understand our model, we can also visualize how the features impact the house price. This can be done using various plotting techniques, like 2D or 3D scatter plots, which show the relationship between the features and the predicted prices. Here's an example of how you might plot the data. Matplotlib PyPlot is used for creating 2D and 3D plots. Axis 3D allows us to create 3D scatter plots. ax.scatter creates a 3D scatter plot of square footage and price, showing how these variables interact. Another important step in understanding your linear regression model is interpreting the coefficients. These coefficients tell us how much the dependent variable house price is expected to change with a 1-unit change in each independent variable, assuming all other variables are held constant. Here we will write coefficient equal to model.coe. As shown, this gives us the coefficients for each feature like square footage, number of bedrooms, house age. Then for intercept, we will write intercept equal to model.intercept. This gives us the intercept value. These values helps to explain how each feature influences the predicted house price. And there you have it. We've successfully used Python to apply multiple linear regression to a real-world dataset, predicting house prices based on square footage, number of bedrooms. We've covered how to load data, train a model, make predictions, and even interpret the model's coefficients. In the next video, we'll delve into logistic regression. If you find this tutorial helpful, don't forget to like, subscribe, and hit the bell icon so you won't miss any future videos. If you have any questions or want us to cover specific topics, drop them in the comments below. See you next time!